Okay, so for dry lab number 2, the first page of dry lab number 2 are conversion factors. And I didn't like the way they did it. So I redid page 1 of dry lab number 2. So you might want to, for next week's lab, download that page and print it off and bring it, or just have it available on your phone or something. And the reason why I didn't like it is yesterday we talked about significant figures and something defined. If something's by definition, it has infinite sig figs. Well, everything in boldface here is by definition. Well, if you look at page 1 of dry number 2, it's not obvious what. I know it's just, isn't it just italics? I think.
It's just text. It's not
Yeah,
even
it's just italics, which is,
italics.
yeah. And so anyway, I boldfaced it. So, and I also did some more with metric system down here. So I like mine better. What can I say? I think it's easier to interpret. So that's not, you won't need that until next week. If you'd like to start on it sooner, by all means, you can have it totally done at home and bring it in and just say, I don't need to be in lab today, and then go home. That's fine. Okay, that's totally fine. Or you can come and I can help you do the problems. Now, lab 2 is significantly more challenging than lab 1, just FYI, because you're going through word problems, and they're like, what, 7 pages of word problems, something crazy like that. So there's a lot. And that is one really weak area of students going into 1A and 2A and 3A are problems, how to set them up. That's why I spent a lot of time in this class focusing on that and giving you strategies to work that. All right, so normally, if there are decimals in the conversion, it's not by definition, except for a few. Like 1 inch is defined as 2.54 centimeters, exactly. So that would be an infinite sig fig. As opposed to mass, for example, a pound is equal to 453.59 grams. And notice it's not boldface. That means it's an approximation. So you'd have to use sig figs for that. So that'd be 5 sig figs. Now you're going to be, the metric system is wonderful. And you can thank Ronald Reagan for killing it. We spent millions of dollars converting signs and all this stuff during the Carter administration to convert our country over. You know, there are 5 countries in the world that don't use metric. We're one of them. It's like, but anyway, metric system is really cool. I cook a lot, and a lot of times everything's in grams and temperatures in centigrade or Celsius. So I'm, of course, being a chemist, I'm very comfortable with the metric system, but most cooks are not. They're used to a cup. One of the problems with using the English system is an ounce. There are 2 kinds of ounces. There's a dry ounce and a fluid ounce. How do you know which is which?
Fluid ounces.
Yeah, fluid ounces you measure in a cup. Dry ounces you measure on a scale. You know, and it's like, but they both say ounces, you know, and it's like, so it's not in the metric system, I might add. Okay. All right. So, from now to the end of the semester, we're going to be using these 4 steps to solve problems every single time. Now, the issue here is, number 1, balance the chemical equation. So you have to ask yourself, is there a chemical equation going on? If there's no chemical equation going on, skip it. Now we're going to find towards the end of the semester, that's all there is, are chemical equations going on and the problems. So you've got to balance the equation. And we have a whole bunch of stuff about balancing equations. So don't have to worry about that at all. So this first unit 1, there's going to be no chemical equations going on. So really, for this unit, it's really 3 steps. What's given? What are we trying to calculate? And then we do the setup. What's given goes on the left. What we're trying to calculate goes on the right. And then the idea here is, you'll see in a minute why I said this, cancel the given. Has to be cancel the given, okay? And we're talking about units here. Okay, so just real quickly, we'll be using this time and again throughout the semester. How do we know a chemical equation is going on? Gases produce, bubbles, basically. Something is bubbling, chemical reactions going on. Color change. Typically, this is the one that's most obvious. Does it get hot or cold? Now, during these processes, bonds are broken and reformed. This is not obvious, but this is what's going on underneath the covers. Okay, so when you dump something together, 2 solutions, and all of a sudden there's white precipitate or a white solid form, up, chemical reaction. So we're not going to, and again, unit 1, we're not going to be seeing these, but these are important to be aware of. Number 4 is kind of like, is what's going on in all 3 of these. Okay, and we're going to be using something called conversion factors for the rest of the semester, particularly in units 1, 4, and 5. So a conversion factor is a fraction that's equal to 1. So let me show you what I mean by that. Now, this is a tough one. How many are in a dozen? 12. Gosh, you all got that right. Okay, so okay, 1 dozen equals 12. Counting. And this is one of those by definition. So this would have infinite. So this is not a 2 sig fig and a 1 sig fig. This is infinite because it's by definition. However, this is not a fraction. So conversion factors have to be a fraction. So we're going to make it into a fraction. So basically, now it's a fraction. And because fractions, if the denominator and numerator are equal, that fraction is equal to 1. Now, if they're not even, it's not a conversion factor because it has to be equal to 1. Now, anytime you have a conversion factor, you really have 2 conversion factors. So we have 1 dozen over 12. We have 12 over 1 dozen. Now, these 2 have to be equal. And as long as they're equal to 1. So you're going to be learning a number of conversion factors throughout the semester. And remember, you always have 2 for every 1 because you flip it. And the question is, whenever you're trying to solve a word problem, you go, do I multiply or divide? I don't know. I'm going to show you a way where you'll know every single time what to do. You'll either divide or multiply. Now, some of the problems we're going to be doing, some of you who are comfortable with math will go, oh, I just divide that by 12.5. which is fine, except for one problem. If I gave that as a test problem for 10 points, you'd get 1 point for the correct answer, but not for setup. Okay, and that sounds picky, but the reason for that is when we get into stuff that you don't know about, the setup is crucial. So let's do a really difficult problem here. How many donuts are there in 1.24 dozen? Okay, first thing we're going to do is we go through our 3 steps. Step number 2 is what's given. But to figure out what's given, you look for the number. In this case, the number is 1.24. And then with the associated unit. And the other unit with no number is what we're trying to calculate. So calculate given. And this is where your flare or your highlighters come into play. And everything else, ignore. All you care about is 1.24 dozen. How many donuts is that? Okay, so if you look through those steps, given goes on the left. Calculate goes on the right. And the last step is the setup. Now, to go from given to calculate, we have to use conversion factors. So what conversion factor do we know about dozen? Yeah, well, there's 2 fractions. The question is, which of those 2 fractions do we use? Okay, so let me show you a foolproof way to know which one. If you go back up to here, it says cancel the given. Cancel the given. And what do I mean by that? Well, the given is dozen. So I'm going to multiply that 1.24 dozen by a fraction that's going to cancel the dozen unit. So as a quick review of elementary algebra, if I multiply A times C over A, what does that equal? C. Why? The A's cancel, right? So we're going to treat units like a variable. Instead of A, it's going to be dozen. So this is the given. And that's what we're trying to calculate. And we're going to take that conversion factor, that the one where the given cancels. So that means doesn't have to be in the bottom. So we're going to multiply. No need to guess because it cancels. Boom, every single time. No guessing required at all. And this process is called unit cancellation. It's also called dimensional analysis. But it's basically just cancel out the units. So you're basically going to be canceling out units till you get what you want. We're going to keep throwing conversion factors in there till you get what you want. Now, what we're doing is we're really playing a game. We're playing a game to rename dozen. So we can start multiplying this by conversion factors. Remember, those are equal to 1. So 1 times anything isn't changing the number. All we're doing is renaming it. All we're doing. Okay, so the dozen cancel. And we're all done now. That's setup. 10-point problem. That's 9 points. If you can work your calculator, that's 1 point. Okay, are we done yet? Sig figs. Remember now, when we multiply or divide, our answer is the least number of significant figures. So let's go through sig figs here and determine how many sig figs are going to be in our answer. All right, how many sig figs are in 1.24? 3 sig figs. What about 12 over 1 dozen? Infinite, right? Because it's by definition. So our answer needs to be 3 sig figs. Our answer right now has how many sig figs? 4. So we got to cut it back. So you go to the 4th place, and that's 5 or greater. So that kicks that first 8 up to a 9. So our answer is 14.9 donuts. And I'm going to write 3SF just for clarification. So 9 points. Have we used our calculator yet? Not yet. So you can go through the whole test without a calculator, assuming your setups are all right, and get 90%, which is an A, without touching your calculator. Because that's how important setups are. Now, a lot of professors that I know, I don't know all the professors in this department, but most of them have non-multiple choice, and they have a preponderance of points for the setup. Very similar to the way I grade. I don't know everyone here very well because there's constant turnover of new people. And I'm only here 2 days a week on Fridays. No one's here on Saturdays. So I don't really get to interface much with the other faculty. They know who I am. My picture's on the board in there. If you go by, you'll see all the faculty pictures. That's about it. So anyway, does this make sense, this process? This is the official process. Unit cancellation. We can kind of do a reverse version of that. Kind of a similar problem, only in reverse. How many does are in 45 donuts? So we go, what's given? 45. What are we trying to calculate? How many dozen? So given goes on the left. To calculate on the right. Okay, and conversion factors. We have two conversion factors. Which one's going to cancel? What goes in the bottom? 12, yes. Okay, let's look at sig figs. We have two sig figs, infinite sig figs. So our answer is going to have two sig figs. So that means it's go to the third place, kicks that up. Now, sometimes the first step doesn't get you to what you're trying to calculate. Sometimes you have to have another conversion factor, or maybe even another one. Now, on test one, you're going to have a take-home problem. And the take-home problems, I'm going to give you 3 days to work because they're challenging. And it's going to be a multiple conversion. And it's going to be practical. I've been doing this for these take-home problems for this kind of a class for many, many years. Yeah. Oh, yeah, for sure. His question was, what about an example of a multi-step? Yeah, we're going to do, I just want to make sure this one stepper is obvious. So, practical problems. For example, one problem was, this was quite a while ago, probably 12 years ago, when China was mainly burning oil for electricity. China at that time used half the oil in the world to burn for electricity. And when you look at the number of barrels of oil burned versus the rest of the world, it was equal. So the rest of the world versus China, it was really amazing. So what I did is I said, how many grams of carbon dioxide is produced? And then I gave a ratio of gallons to grams. But I gave you a whole sheet of assumptions, like 35 or 40 assumptions. And you had to go through and say, I don't need that one. I don't need that one. Oh, that one's real important. I don't need that one. So you're going to go through these assumptions and figure out what's superfluous and what's not. And they're going to use those conversion factors to work out your problem. Another one was when jets burn kerosene, jet fuel, they produce carbon dioxide and water. So I said 737 taken off from Seattle takes 2.5 hours to get to Los Angeles. How much ice is produced? So you got to figure out, and I gave you the flow rates on the fuel, another conversion factor. And you had to figure out how much ice is produced per gallon of jet fuel, which I gave you a ratio for. Now, when we get to unit 4, I'm not going to give you those ratios. Those you have to figure out based on the chemistry. But unit 1 take-home test is going to be easier. All right. So let's do some more examples here. So let's do this one here. How many micrograms are in 4.56 grams? And this is a metric conversion problem. So this is the base unit. So in the metric system, we have base units. So it's like a gram, a liter. Those are like the base units. And then there are sub prefixes that determine the size of that. So this is an adjective modifies that noun. The adjective determines how big or small that subunit is. Now, how do you know what size it is? That's that conversion table I gave you. Up here. So we have a microgram. I gave you two examples of how to use the microgram conversion. Okay. Okay, that's not a conversion factor. So what we can do is make it into a conversion factor. Okay, so those are two conversion factors for micrograms in relationship to grams. Okay. There's another conversion factor as well, and that's using the second column. So all those are equal to 1. Now, when you're writing these, frequently as an error, students will put 10 to the minus 6 micrograms and 1 gram down here. Now, I want you to analyze your relationship here. Okay. Is a microgram smaller or bigger than a gram? Smaller. So that means this down here has to be small compared to that. Otherwise, it's not equal to 1. Same down here. We have 1 gram. It's going to take 1,000,000 micrograms equal 1 gram. So this is really small, big number. Big, small number. So I think big and small have to be together on these conversions. Big number, small. Big unit, small number. Okay. So when you write your conversion factor, look at it and see if it makes sense. That way you don't have to memorize these. Because there's a, I'm trying to move the screen. Now you've heard of most of these. Tera. Now with computers, it's a terabyte this, a terabyte that. My external drive on this thing is 2 terabytes. It's terabytes is used frequently these days. Giga frequently used again in the telecommunication industry as bandwidth measurement. Gigabits. Mega is 1,000,000. So some of these are opposite. Micro and mega. Both of them have 1,000,000 related to them. Nano, 10 to the minus 9th. Giga, 10 to the 9th. So those kind of go in pairs. Centi, most of you already know that one because they're 100 cents and a dollar. 100 years and a century. Milli is a thousands. Kilo and milli kind of are paired together. Okay, so let's go back to our original problem here. So we have these 4 conversion factors relating micrograms to grams, grams to micrograms. Okay, so a nanogram is a billionth of a gram. So what's given? 4.56 grams. What are we trying to calculate? Nanograms. Given on the left, nanograms on the right. So given has to cancel. So what goes on the bottom of that conversion factor? Grams, exactly. So the nanograms goes on top. Now the trick here is, what are the numbers? Which is smaller, nanograms or grams? Nanograms. So that means we have to have a big number here. Small, big. So that's our conversion factor. Now there's another one we could have used also. We could have used one. We use that also. Okay, so we just grind this baby out. So do we need a calculator for this? Yes, the answer is 4.5 times 10 to the 9 nanograms. 2 sig figs, infinite sig figs. And so our answer is already in 2 sig figs, so that's our answer. Yeah. I'm sorry? Oh, I'm sorry. My G melted into the 6. So yeah, it's 3. I'm sorry. Okay, so we need to round that to, so the answer is 4.6 times 10 to the 9. Sorry? Oh yeah, I'm still in historical mode of 2 sig figs. Yes. Oh my gosh. Thank you for keeping me. Yeah, 3 sig figs. That should be 3 sig figs. Okay, OPA number 1 for today. Okay, plane travels from San Francisco to LA, takes 1.54 hours. Jet burns fuel at 3.45 pounds per second. How much fuel does the plane use? Okay, so what's given? Huh? Well, that's a conversion factor. See the per. So what's given is that 1.54. And what are we trying to calculate? Trying to calculate fuel. Okay, so given goes on the left. Pounds fuel on the right. Okay. So do we have a conversion factor that has hours and fuel in it, or hours and pounds
What's 4 or 5 pounds per
per second though? Yeah. So there's no one-step conversion we have. One conversion factor we have is and then we have the inverse of that. That one won't work because the given does not cancel if we use that conversion factor. So what can we do to fix that problem? Yeah. And what does that give us? Don't do the multiplication here, but what does it give us? Gives us a number of seconds. Now we can use this guy. And until we have seconds, we can't use it. So his point is convert hours to seconds. So that's our first conversion factor. What goes on the bottom? It's just got to cancel. That's right. Got to do minute on top. Now we have minutes. What do we need? We don't need minutes. We need seconds. Okay. Now we can use this guy because that's in seconds. Notice how everything cancels. Everything cancels except what? Pounds. What are we trying to calculate? Pounds. So the setup is right, assuming your ratios are correct. Okay, so we're just going to do this is 3 sig figs. This is infinite, 3 sig figs. Answer is going to be 3 sig figs. So let me move this pound over here. So how many sig figs is our answer going to have? 3. Okay, which is going to be 1.91. I got a room again here. Yeah. The big long answer my calculator gave me, I went to 3 sig figs. Have you done the calculation on yours? Yeah, you'll see it's big long number. And depending what mode your calculator is in, it'll either tell you this way or it'll give you the 19100 after you go to 3 sig figs. Okay, does everyone see now the beauty of unit cancellation? Everything cancels except what we're trying to calculate. This is a 3-step problem. It can be 1 step or 19 steps. Everything's got to cancel except for what you're trying to calculate. Let's see, do I have any other problems? Okay. We've been working in one dimension. What if you're working in 2 dimensions or 3 dimensions, whatever? We can still use unit cancellation. It's a little different, but it's basically the same thing. Okay, so we have given is 1.2 or 1.12 square kilometers or kilometers. We're trying to calculate square inches. Okay, so let's do, let me modify this problem a little bit so that it's, let's see, okay, so how many square inches is in 1.12 square centimeters? Okay, so we go up to our conversion table. Do we see any squared units up there? Or any cube up there? No, but we don't need that because we can convert these guys into squared and cubic units. So we know that 1 inch is equal to 254 centimeters. And that's by definition. So it's infinite. Okay. But we are going to work in terms of squared stuff now. So we have okay, these are not equal, but if we square this, let's rewrite this to inches. So if we square both sides, that'll give us square centimeters. Square both sides, we end up with square inches. 1 squared is what? 1 times 1 is, this is a tough one, right? 1. So 1 square inch is equal to 2.54 squared. Okay, that's our new square conversion factor. So all we've done is we've converted a one-dimensional conversion factor into a two-dimensional one. And if we're working with cubic stuff, this would be cubed and that would be cubed. So we'd have to have 254 cubed then. So it'd be 254 times 254 times 254. Okay. All right, so that means we have a conversion factors. We have two conversion factors. Now, which one of those do we use? Givens got to cancel. So that means the square centimeters have to be in the bottom. Otherwise, it won't cancel. Now, question is, what are the sig figs for our new squared conversion factor? Is this 5 sig figs? Yeah, so we started with an exact. That's exact. That means it's infinite. So if we use infinite sig figs, what we end up with is going to be significant, infinite sig figs as well. So this has infinite sig figs. And so our answer is going to be 3 sig figs. So whenever you see the squared, you just go and make your own conversion factors from the linear one. If it's squared, you square everything. If it's cubic, you cube everything. Okay, does that make sense? And you just need to practice this 30 or 40 times. You get it down. All right, so and then there's one other type of problem. Um, let's look at this guy here. Any questions about that last problem? Okay, so let's look at, you saw a sign that said 34.5 kilometers per hour. What's the speed in miles per hour? What's given? Yeah, so the given is a fraction. That's what's key about this. We're not starting with just a number. We're starting with a fraction. That's what makes this problem different. Okay, so we're starting with that's the given. We're going to end up with miles per hour. Okay, so whenever you start with a fraction, you've really got two problems. You've got to convert the kilometers to miles, and you've got to convert the hours to hours. Well, that's already done. So all we need to worry about is the numerator, excuse me, the numerator here, getting the kilometers over to miles. If this was kilometers per second, then we'd have to convert the seconds to hours, okay? So whenever you have a fraction as a given, it's two problems. You're doing numerator on top, conversion, denominator on the bottom, conversion, okay? Now, we're going to go through a bunch of examples. So some of these you're going like, wow. We're going to go through a bunch of these examples. I really believe in lots and lots of examples, okay? So now we have to get kilometers over to miles, okay? So what's one conversion factor? Now we're working on kilometers now. Ignore the hours on the bottom. So how do we get kilometers to something we can work with? Now we're looking at miles. Is there a conversion factor to go from kilometers to miles? I don't know. Let's look. $16.09 kilometers per mile. Okay, so let's see, where are we here? So kilometers has to cancel. And that's why the kilometers are on the bottom. Kilometers are shorter than miles. Is that 1609? Remember? Okay, all right. So now we've converted the kilometers to miles. Hours are still on the bottom. And that's where we want it to stay. We want kilometers on the bottom, hours on the bottom on both. So we're done. So 21.4 miles per hour. That's why in your speedometer in your car, you'll notice that the kilometers per hour are always more than your miles per hour, because a kilometer is shorter than a mile. In fact, if you're into biking, there's two kinds of centuries. Anyone bike? Okay, if you do a century, that's 100 miles. If you do a metric century, that's 100 kilometers, which is about 67 miles. Anyway, in your car, kilometers are always faster. Okay, so those are the examples I wanted to go over today. And on Friday, I'm going to go over more of these. Okay, more of these. I want to show you lots of versions of these. Lots of conversions on the metric, lots of conversions, multi-step, square and cubic examples, and starting with a fraction, ending with a fraction. Now, dry lab number 2 has got a whole bunch of these. If you'd like to start on that tonight, you're more than welcome to do it. Okay, so that's what I wanted to cover today. Okay.
Did you say dry lab number 2?
Hmm?
Did you say dry lab number 2?
Yeah.
Am I doing one?
You are doing one. Parallel number 2 is for next week.
Next.
I'm just saying if you want to get a head start. Okay. Raise your, I want you to be honest now. Who feels relatively comfortable doing unit cancellation? Okay. Good. Good. Okay. For those who didn't raise your hand, we just need to do a whole bunch more problems as examples. I want no one in here to not know this. This is crucial for your next chemistry class. Physics does the same thing. Engineering classes, same thing. Unit cancellation is a very, very universally accepted problem-solving technique. And it has served me well throughout my many years teaching. Because students, after a while, they go, got to cancel that given. What needs to go in the bottom? Boom, every single time. Boom, boom, boom. And you do it enough, you'll automatically think that way. What are my conversion factors? The world runs by conversion factors. These are just fractions. Which one do I use? The one that cancels it. Okay. All right. So that's it for today. And Friday, I want to go over more problem examples. Now that'll get you set up for dry lab number 2. Yeah. You say you haven't purchased lab? Okay, if you go to, you're on Canvas, right? Go to Canvas, files, lab related, and you'll see dry lab number 1. Just use it on your phone. Yeah. No, the syllabus is what? Oh, it doesn't matter. No, that's if you, some teachers like that, but it really doesn't matter because Canvas will separate you anyway. So it'll automatically put you in the right lab section. So you can put it down if you want Friday. It doesn't make any difference. Bye. So does this make sense?
Gonna have to re-listen to the lecture. Again.
No,
I only understood the first two.
We're gonna hit this again though on Friday. So because I'm just this is really crucial for what's your career path? Okay, so you're gonna take 2A and 2A, and they'll go over this again in 2A as well. But you should be really solid when you hit 2A after you take this course.
It's funny because you do the entire notes. Like the full thing, like, okay, how can I convert this? How do I do it work?
Yeah, I mean the medical, you're always doing this stuff.
Yeah, like literally do like these like super long ones, like micrograms all the time. It's like, how can I convert that to that? So let's see.
Yeah, this way.
Where do we find the recorded lectures?
Oh, go to module. And go down to unit 1. And that's what it was from yesterday.
Oh, perfect. Okay, cool. I swear I searched all over and I couldn't find it.
Well, it's also in pages,
Okay,
but I don't tell people that. I
This
just
is
say we're doing
easy.
everything in modules.
okay, perfect. Thank you.
Sure. I'm sorry, say again?
Can I put an accent to join the class?
Yes. Go to the lab today. You
I
know,
went there yesterday.
okay, so I need to give you a Friday ad code then. Let me do it right now.